Welcome. In this video, I'll be talking about an example calculating the smallest transmission period and the data rate for a combined signal. Suppose you have a signal that looks as follows: x of t equals a1 sine 2 pi times 1500 hertz times t plus a2 sine of 2 pi times 2000 hertz times t. We need to find the transmission period. As we learned from before, the transmission period is equal to the L for a combined signal is LCM of L1 T1 T2, which is equal to LCM of 1 over F1 1 over F2 . Okay, so that's equal to so we can say T1 is equal to, we have the frequency here, so that would be 1 over 1500 hertz, which is equal to approximately 0.00067 seconds, and T2 is equal to 1 over 2000, this one here, hertz, which is approximately 0.0005 seconds. And we need to find the LCM of T1 and T2, but right now we have decimals, so what we can do is turn this into, to make it work, we can turn to simplify, we're going to convert both periods to a common unit. We can call them microseconds. So we move the decimal place to the right 6 units. Okay, 1 2 3 4 5 6. So the answer, so this will be equal to 670 microseconds. And now this one, 1 2 3 4 5 6, that's equal to 500 microseconds. Now we can find, so the LCM of 670 microseconds and 500 microseconds. So LCM is least common multiple. So these are approximately 500 each. So if I multiply, so the least common multiple would be approximately 1000 microseconds. That would be our answer, or approximately equal to, would be equal to 0.001 seconds. Now we're gonna calculate the data rate for a combined for this combined signal. So F1 is 1500 and A2 and F2 is 2000. Okay, so let's see. Remember, F1 is equal to, on the back it was 1500 hertz, and F2 is equal to 2000 hertz. So we assume each component transmits a different number of bits per cycle. Let's say the first component transmits 3 bits, so N1 will be equal to 3, and the second component that transmits 2 bits per cycle, so that will be N2 equal to 2. So we have N1 equal to 3 and N2 equal to 2. Okay, so let's compute the first data rate. R1 will be equal to F1 times N1, which is equal to 1500 times 3, which is equal to 4500 bits per second. And R2 will be equal to F2 times N2, which is equal to 2000 times 2, which is equal to 4000 bits per second. But remember from a previous video that total R is equal to R1 plus R2, which is equal to, so each signal contributes to a different data rate, and we add it together to find the total data rate. So 4500 plus 4000, that's equal to 8500 bits per second. This example shows how the smallest transmission period and the combined data rate are determined for a signal composed of multiple sinusoidal components. Adjusting the frequencies or bits per cycle can significantly impact the overall data transmission capacity. Thank you for watching. Please subscribe.